Welcome back. We're into lesson 2.6, ray diagrams. We're going to be putting an object in front of a mirror, projecting a few rays off of it as we learned to do in 2.4 and 2.5, and those rays are going to tell us where the image appears in the mirror. For our first example, I've got a concave mirror, radius of 6 centimeters. Our object is 2 centimeters high and it's 8 centimeters from the mirror. I'm using a sketching guide just like the one you have printable on the Moodle site. I've highlighted the concave mirror. I've kind of erased the convex mirror so it doesn't get in our way. They say that the radius is 6 centimeters, so starting from the surface of the mirror, I can measure out 1, 2, 3, 4, 5, 6. There's my mirror's center. If you take half the radius, 3 centimeters, that's our focal length. So starting again from the surface of the mirror, you can measure out 1, 2, 3 centimeters. There's our focus. Tag that with an F so it's crystal clear what it is. The center's not so critical for what we're doing, but the focus is very important, and we saw why in the last couple of lessons. The focus is a point that all of our rays are going to go through. Anytime you put in a ray parallel to the axis on its way in, it's going to reflect out through the focus. Anytime you put in a ray through the focus, it's going to come out parallel. These are easy rays to draw, they're very predictable, and they're very helpful to us when we're trying to find an image. So let's get an object in here and then we'll see where its image appears. It says here the object is 2 centimeters high and it's 8 centimeters away from the mirror. So starting here, 1, 2, 3, 4, 5, 6, 7, 8 centimeters out. This is where our object is, and our object is 2 centimeters high. So there we are. We don't really care what the object is. We always draw it shaped like an arrow, and the tip of the arrow represents the very top of the object. So these are the two rays we want to draw. We're going to have one coming in parallel, and it's going to bounce out through the focus. We're going to have another ray that goes in through the focus. It's going to bounce out parallel. Let's see how that works out here. First ray, starting from the top of the object, goes in parallel to the axis, and when it reflects out, it's going to pass through the focus. So the reflected ray goes out like so, right through the middle of the focal point. You want to extend this ray in both directions because, as you've seen, sometimes we have images that appear behind the mirror on the virtual side, and sometimes we have images that form out in the air where we are on the real side. We don't know which kind we're going to get just yet, so you extend this reflected ray all the way back and all the way front. The second ray is supposed to go in through the focus and out parallel. So starting again from the top of our object, we draw a ray that goes in through the focus and keeps going until it strikes the mirror. Now it's supposed to reflect out parallel to the axis. Again, I don't know which way our image is going to form, so I have to extend this ray in both directions like so. Up here on the real object, these two rays were together, and this is why you can see the real object, because all these rays are converged at that point. The only other place that they converge, the reflected rays, is right here. This is another point where those rays are all together. Right here, it's as if you're seeing the original object again. This is where our image forms. Our image is going to be like this, with its top right where those two rays come together. This is where the original light came from, and this is where that same image forms again. So, looking at this arrow compared to the original arrow, what can we tell about it? This one is clearly shorter. The original was 2 centimeters high. This one is 1 centimeter and a bit. So this image is reduced. The original arrow was pointing up. This new arrow is pointing down. So our new image is inverted. And this arrow is not back behind the mirror where we're used to seeing the images in a flat mirror. This image is out in the same space that we are in. This is a real image. What does that mean? It means that you can't see it unless you put a screen in that location, and then you'll see the projected image reflected on the screen.